Hi, I'm Phil, and we're celebrating Vivid in Sydney. So we have light shows, and they all happen every year at the beginning of winter. And I'm going to do something special for makers. I'm going to look at a light show using neopixels and the microbit computer. So I'm doing this for the Ravenswood School as part of the CSIRO industry partnership. So what's a neopixel? It's a color changing LED, and they come together as a chain. The name itself comes from Adafruit, and they use the WS2812 integrated light source. So let's have a look at the different forms. I'm going to use the Grove neopixel, but they do come in other forms too. And we're going to use a linear string, but I also have circular and single neopixels. So for the linear ones, we'll be using the strip of 30 LEDs in a meter, and that gets connected to a Grove connector, then onto BitMaker and microbit. So let's have a look at some of the projects. So the first projects I worked on were timers, including the timer, traffic signals, a railway crossing, and an alarm clock. So you can see those here. The alarm clock is coming up now. Okay, here's the alarm clock, and I've showed that on a previous video. Today I'm going to have a look at music, and the next video we'll have a look at events. So in the music area, the one that I'm interested in is getting a note algorithm and driving the neopixel lights. So this is going to synchronize the music with the lights. So you can see my desktop arrangement. I'm looking at implementing the colors of Boomwackers, and these are all the Boomwacker devices that I've got available, including sheet music and instruments like the tubes, the Boomwacker tubes, the bells, the xylophone, and we've even got it painted on a MIDI musical instrument. And for this project, we're going to put the lights on and synchronize that with the music. So let's have a look at my objective. What I'm trying to do is implement the note algorithm to play music on microbit. I'm going to scan a full 8-octave piano keyboard, and I'm going to synchronize that with the Boomwacker colored lights. But before we do that, we need to know how the notes are implemented by changing the audio frequency. So over, say, 5 octaves, you can see that the C doubles up as you go up an octave. So we'll be using that when we implement that on our software. For the design, when you press button A, it will increase an octave, decrease it by pressing button B, and you can go back to the default octave, which is number 4, or middle C, by pressing A and B. And if you press the logo button, it will go through the scales. So the devices that I'm using are the Grove RGB LED strip, and I'm using a rotary angle sensor to change the colors. I'm using a Grove Speaker Plus to improve on the sound quality from the microbit, and also a bit maker where the Grove cable and Grove devices are connected, as well as the microbit. So you can actually see what the connections look like. We've got a PC, microbit, and BitMaker. And on port 0, we've got the Grove Speaker Plus. On port 16, we've got the Grove NeoPixel strip, and we've also got a Grove 4-digit display. Okay, so let's have a look at the code. So here's the code, and we'll go through that in detail now. So what I'll do is I'll switch over to the Chrome program, and here you can see it here. Starts on the left with startup. There's nothing in forever. There's button A, and what happens when you press button A, button B, button A plus B, the logo button, and on the right is where we show the colors. So let's zoom in and see if we can actually see that in a bit more detail. So on startup, we're setting up the NeoPixel strip, and we're dividing that into a low and a high range. So each of those has 15 LEDs. And then we clear the strip. We then set up the 4-digit display, and we move on to the setting up the parameters. The number of notes is 8, so we've got a maximum of 8 octaves, and we've got 8 notes in a scale. And we define the scale from C back on to D. We're actually going through a little bit beyond the scale itself to include the next C and D. And we start off with octave 1 by defining the frequencies in that octave. Our minimum octave is going to be 1, the maximum is 8, and the default is 4. We switch on the speaker, and we have a note offset of 5 there. So when we play button A, we show a red-blue on our NeoPixel LED array. We increase the octave. So the purpose of pressing button A is to go up an octave. And if we're at the maximum, we just stay on the maximum. And we show that number on the microbit. We do the opposite with B. We go down an octave, and we reverse the colors of red and blue on the LED array. When we press A and B together, we go to the default octave, which is number 4. When we press the logo button, this is where the activity all happens. We start off by showing a rainbow on our NeoPixel LED. We wait a second, and then we go through the scales, going using a pointer to the scales with note index, and we go up to the maximum number, which is 8. And here we're setting the note color to the note index value. We show that, and there's a function over there that goes through the selection of the colors. And we then also show on the microbit LED the particular note from C, D, all the way through. So we then show that on the microbit LED array, and we also show the note frequency on the 4-digit display. Then we play the note. So we play the note. We start off with a start frequency and an end frequency. Uses a slight offset to try and give it a bit more realism to the playing of the note. And we show that string over here. We could probably get rid of one of those. That one can go. We don't need it. It's duplicate. And in that function of show, it depends on the color value. If it's 0, it's C, so we show red. And we go through the rainbow spectrum depending on the value of the color number, which is the same as the note. Okay, so we can actually see that being played. If we go over to our virtual microbit over here, you can see that we've got an octave of 5. And if we want to go through the scale, we just simply press the logo button. So it's now going through the scales at the moment, and it's simulating that over here. Okay, so that's it from me. Watch the desktop demo where I look at the Boomwacker color codes and also getting this to work on a microbit. Finally, we're going to have a look at the references. So if we open up the references here, you can get more from the microbit website, where you can learn how to use neopixels on the microbit computer. And Adafruit have quite a number of interesting articles, including lessons on using the neopixels and all about the neopixels. The State Library of Queensland has a good introduction to neopixels, as well as the London School of Arts. So there's quite a bit on the internet. And also you can see how I've used color on my M5Stack Fire computer. So I've implemented on this project on the microbit, but I've also done a similar project with the M5Stack Fire computer. And that's all for me for the time being. And what we'll do now is end the video. This is my full range of Boomwacker musical instruments. So we can see the tubes over here. This is where it all started off. We can get the C, bang it on the table, and we get the note C. And we could move up one octave. This is C again. And we can get all the notes on the scale just from the tubes. But it's also been implemented on bells. And we've got it on the xylophone. And we've also got it on the keyboard. So this is a MIDI musical instrument where we've put the Boomwacker stickers on the keys of the piano. And we've also got sheet music. So if we wanted to play some Irish songs, we've got the Boomwacker color code and the Irish songs. You can have a look at them in here. So here's the Irish Washerwoman, and you can see the color code. So we've got Drunken Sailor and Oh Danny Boy. So and Carmen. So we've got classical music and we've got simple music for kids. Now we've implemented all of this on the microbit computer. So the microbit computer will show the note on its LED display, and it will also show the frequency of that note, and you can increase and decrease the octave by pressing button A or B. So when you press the logo button, it will go through the whole scale. Let's have a look. So here we have it. That's the microbit, and we can go up an octave. We're just going through the scales again. I'll reset it. So we're resetting it now, and we're going to go up an octave. So when it goes up an octave, it shows the two color code, blue and red. And when we go down, it just reverses that. So we go back to octave 4, and we'll go back up to octave 6, and we'll play that scale. And it's showing the frequency of the note on the 4-digit LED display. And that's Boomwackers, both on tubes, on bells, a xylophone, and now on the microbit.